Welcome back to our series of videos on data engineering. In this next 2 or 3 videos, we are going to see how we can deploy a machine learning model into GitHub, and then how we can build an application on Streamlit, which can be provided to a user so that the user uh, can give an input on the app and the user gets a prediction. This is considered to be the last step in the model deployment process. So once you have developed a model and you have deployed it into a production environment, the last stage is to provide the user an app which will connect to the deployed model in the production endpoint, and the user will be able to interact with the model through this app. Now, this app can be custom built, but these days there are quite a few platforms that are available which help you to build app and that connects directly with GitHub once you have all the relevant files for model deployment on GitHub. One such app development platform for the purpose of model deployment and providing the interface to the user is Streamlit. So Streamlit is available both in the free version and the pro version. We'll use the free version and we'll see that how we can create an app on Streamlit that will interact with the model that has been deployed. Streamlit works once the model has been deployed on GitHub. So first we'll go through the process of building a model. Here, our objective is not really to build a great model. The objective is to see the process of how a model is built and then how the model is deployed on GitHub and then how the Streamlit app is, we connect the Streamlit app to the model that has been deployed on GitHub. So this is a Colab notebook. These days, of course, you can create all these codes using Gemini and using prompt. This is a slightly older code, so I have not used Gemini at that point of time. But these days, you don't have to write these codes by hand. You can easily use Gemini and provide the relevant prompt which will create the codes for you. I always do that these days. So we are predicting diabetes, and this is a very common data set that we're using to predict diabetes. So initially, we're importing all the files and libraries, which you're already aware of. Then we are reading the diabetes data set. So I'm not running this file again, but if you have to run it, then you have to upload the diabetes file over here and then run it from there. So once you run it, it will be able to read the head of the data. So it is reading the head of the data. It is also giving the shape of the data. That means there are 768 rows and 9 columns. 9 columns are these features, pregnancies, glucose, blood pressure, etc. And the target is outcome, which is 1 or 0. 1 means the person is diabetic and 0 means the person is non-diabetic. We are also using this describe function to find out some statistical data about all these features. All the features here you can see are uh, they are quantitative features, and these are important because when you select the model for training, the right model selection depends on whether the features are all quantitative or all qualitative or a mix of quantitative and qualitative. So because they're all quantitative data, you can get count, mean, standard deviation, etc. We're also seeing whether the data set is imbalanced or balanced. It's very important that you have a balanced data set because otherwise the model may not have enough values of one class to get itself trained. If you have an imbalanced data set, there are methods like artificially imputing data. So here you see that there are 500 observations where the outcome is 0. That means the person is non-diabetic, and there are 268 observations where the person is diabetic. So reasonably, it is a balanced data set. So you can carry forward with this. <clears throat> 。 .
. 。 . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . .
。 . 。 . 。 . 。 . So it is also saying what is the uh, average number of pregnancy or glucose, etc. For where the outcome is zero, that means the person is non-diabetic, whereas the person is diabetic. So here we can see that clearly, if the person is diabetic, the average glucose level is much higher than the average glucose level if the person is non-diabetic. However, if you look at blood pressure, there is not a significant difference in the blood pressure if the person is diabetic or non-diabetic, but there's a big difference in terms of the insulin insulin quantity in the blood or whatever that means if a person is diabetic compared to a person is non-diabetic. And we also see that the age of a diabetic person, average age of a diabetic person is higher than the average age of a non-diabetic person. Okay. So here we have separated the data and the label. So the label or the target is the outcome, and rest of the other values are features. So we have X, which is contains all the features, and we have Y, which contains the label. And then we have split into the train and testing standard process. So 80% is so test size is 0.2. That means 80% of the data we're giving as training for training purpose, and 20% is we are giving for the testing purpose. And we can also see that how many records are there for training and how many records are there for testing. As far as the training is concerned, there is 768 records that are kept for 768 and 8 the total number of records, and out of that 614 are kept for training and 154 are kept for testing. We have used a support vector machine classifier, SVC, support vector machine, okay, and support vector machine classifier to, uh, to do the prediction, and we train the model on support vector machine. And then we are finding out what is the accuracy of the model, and we see that the accuracy of the model is 78.83% on the training data and 77% on the testing data. We all know that it's more important to have the accuracy of the testing data set rather than the training data set because of the concept of bias and variance. So all of these things you have already studied in your normal data science lessons. Now, what we need to do is we need to, so now that the model is built, the whole idea is that I have to give an input of the features to this model to get an output. So no longer the training and testing is over. Now we have to get the actual prediction. So one way of doing that is that I can just give the input values. So these input values, you can see there are 8 input values: 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there are 8 input values, and these 8 input values are corresponding to these values: pregnancy, glucose, blood pressure, etc., in that order. Okay, in that order, in the same order. 5 means pregnancy, 166 means blood pressure, blood sugar, or glucose rather. Okay, so it has to be in the same order. If I give those things as a value, then it can, if I run this, it will go through the model, it will take those values, input values in the model, and it will predict whether the patient is diabetic or non-diabetic. As you can see, it has predicted that the person is diabetic. But this is not what a user can do. This is what a developer can do. So the developer is created this Colab notebook, and the developer, for the purpose of uh, validation, the developer can provide the value of few patient data and get the output whether the person is diabetic or non-diabetic. But you cannot expect this particular Colab notebook to be given to, let's say, a pathologist or a doctor or somebody like that. And you can't expect the pathologist, the doctor, who is an end user, who doesn't have any idea about this Colab notebook, and ask him or her to enter this data in this format and get the prediction. It is very, very cumbersome for the end user to do that. end user is expecting a nicely looking website or an app where the end user will be able to enter all these values, and the end user knows that the first column is pregnancy, second column is glucose. The end user does not have to refer to this sequence of values and uh, enter these values one by one. So this is where the challenge comes in. Okay, if the end user was a developer, there would not have been any issue. But because the end user and the developer are two different set of people, we need to do two things. First of all, we have to have a different environment for this model where the end user will be using the model, whereas the developer may use this in a different environment. The developer may use the model for further fine tuning. So these two has to be segregated. They cannot work in the same environment. Second is the end user has to be given a nice user-friendly interface and application where the end user can enter those values. Okay, so this is where the model deployment and the using an app and connecting the app to the endpoint where the model is deployed comes in. So next video we are going to see first how we are going to create a portable file which we can port easily into another environment, the production environment, and then how we can create an app using Streamlit that will use this uh, particular model and provide the interface with the end user so that the end user can interact with this model. So we'll see that in our next video.